Proof. My topic is about smart car tracking system and accident detection system if any crashes happen. First of all, there are the contents of the slide. There is the problem domain, the opportunity gap, the proposed solution in the industry, the system components, its architecture, that how the communication is being between the Arduino Nano and the Raspberry Pi, the system flowchart, the user interface, and at the end there is the conclusion. First of all, we will go on the problem domain, means what is the problem in the current situation in the industry. We can see that there are many vehicle tracking system in the India, but they are not that they are so much of pricey and don't really catch these crashes in the real time. That why we need an emergency response, which but it is very slow in India. So there are some of the challenges by the people, that is lack of affordable solutions. The second one is no integrated system for real time location and the crash alert. The third one is the slow emergency response, increased facilities. Now the opportunity gap. First of all, we need a low cost embedded system that can track vehicle in the real time, which can send alert via SMS or any dashboard on a real time GPS location if any crashes happens. Secondly, it detect the accident instantly on that time. Then what I propose a solution in the industry is that we will make a smart car tracking system using the Arduino Nano and the Raspberry Pi, in which the key feature is that the real time GPS tracking, the crash detection using the MPU 6050 sensor. The third one is the SMS alert via GSM module, and the last one is the live dashboard on the Raspberry Pi with Google Maps API, or we can use Foilum for this website. The fourth part of the slide is the system components. There is the Arduino Nano, which reads the GPS and crash sensor data and sends the info. The modules which are using for the Arduino Nano communication is GPS module, which is NEOCX for the location tracking. The second one is GSM module SIM800L, which sends the SMS alerts on the dashboard, which receives by the Raspberry Pi. The third one is MPU 6050 sensor, which detect the crashes. The fifth component of the slide is the communication protocols. Here it is mainly on the data transmission, that how the data is being sent between the Arduino and the sensor, the communication between the Arduino and the Raspberry Pi. The first one is the communication between the Arduino Nano and the Raspberry Pi using the USB serial communication. The second one is GPS. The data of the GPS will be sent to the Arduino Nano, and the GSM module will also send its info about the location to the Arduino Nano. And then at the last, the Raspberry Pi will communicate with the Arduino Nano, and it will display on the dashboard using the Python, or we can use the Google Maps API. The sixth one is the system flowchart. Here, that these are the steps that how will the workflow of the system will be flow. That like first of all, the power will be on. Second one, the Arduino initializes the GPS, GSM and MPU 6050 sensors. The third one is that we will get the GPS location, means its latitude and longitude. The fourth one is the monitor crash sensor. If any threshold, means if any accident happens, it will send an alert to the dashboard to the Raspberry Pi. Then the data will be sent to the Raspberry Pi with any USB serial communication. Then the Raspberry Pi will display on the live maps plus the low data, plus it will show alert or at the real time if the crashes happens. Then the GSM module will send an SMS to the emergency contact or of anywhere if on a dashboard, for example. Here are the system flow diagram and the system architecture, that how the system is going, that how it will be start the sending the location to the Arduino Nano, then the communication between the Arduino Nano and the Raspberry Pi using the serial, that how the Raspberry Pi will and data logging into the cloud or files, that how it will display the live map dashboard on the Python or the Google Maps API, and how the sensor are being used and how they are being utilized and how they are being powered. The seventh part is the user interface, that which are the key features. Here are the four main key features. The first one is the real-time map dashboard, which is shown by the Raspberry Pi. The second one is the car position update dynamically, means the GPS tracking system. The third one is the crash alert notification, means that if any crash happens, the GSM module will send an SMS alert to the emergency contact. The fourth one is the SMS alert to registered number. The eighth one is the prototype development, means which of the hardware is used and how will be the programming will happen. The hardware which will use is Arduino Nano, the Raspberry Pi, the GPS module, the GSM module, and MPU 6050 sensor which detect the crash. The second one is the how will the programming will happen. The Arduino IDE, we will use Arduino IDE for the C and C++ for Arduino code, and we will use Python for the Raspberry Pi dashboard. And the prototype which will be tested for the GPS accuracy, the crash detection threshold, and the third one is the SMS alert. The ninth part of the slide is that what are the benefits and what are the impacts. The outcomes are the affordable solution compared to the industry system, because in current type of industry we seen earlier that there is not that much developed system which at the real time it which detect the crashes. The second one is the save life by reducing emergency response. And the third one is the scalable, that how this system is being more scalable in the industry, that can be used in public transport, logistics and private vehicles. And at the end there is a summary that what we have been told is that the problem means the delayed accident response. The second one is the solution, that we are making an amended system prototype combining the GPS, GSM and the crash detection module. The third one is the impact on the industry is that improve road safety. It would provide a real time tracking and provide faster emergency response. Thank you.